This is our Anderson bridge kit for measuring the unknown inductance. So I'll just explain whatever there is on this board. So we have a DC source over here for DC balancing, AC source here for AC balancing. This is the onboard circuit diagram for both DC and AC balance. Here we have a digital null detector. Here we have a selector switch for AC and DC mode. Here we have another range selector switch. Here we have a capacitance bank having 5 different values of capacitor, and another terminal is added over here so that you can use any value of capacitor according to your wish. This is the variable resistance S, and another variable resistance M is over here, and this is our inductance box having 2 different L values. This comes with a detailed manual where the procedure as well as the readings are given in details and the calculations are also given. We will now make the circuit connection for the DC balancing first, and then we will move on to the AC balancing. We have connected the circuit for DC balancing at first. Here is the DC source and it has been connected to these 2 terminals in the circuit. Next, we have connected S, the resistance bank S, to S, the terminals for S over here, the variable resistance. The L inductance has been connected with the terminals for the inductance box. We have connected it to 10 millihenry currently. M here has been shorted because we will not need it for DC balance, we'll need it for AC balance only. C has been connected over here, but you may not connect C. It really doesn't matter for DC balance as C will act here as an open circuit. And P, Q and R, these resistances have already been connected from beforehand. These are all equal to 100 ohms. And here the selector switch will be at DC and this will be at 20 milliampere range. The null detector here has been connected with the terminals for null detector. Now we will just change the values for the resistance S and note the readings in the null detector and find out the DC balancing point. So we will start with the maximum value, that is 10, multiplier of 10, so we will just change it. Here we see the value is decreasing in the null detector. We will keep changing it unless we get a negative value. So we are getting a negative value for 90 ohms. So we will just keep it in the previous one, that is 80 ohms, and try to balance it using this 1 ohm multiplier. So it is decreasing. Again we are getting a negative value for 3 ohms. So we'll keep this at 2 ohms and try to balance it with this 0.1 ohms multiplier. So we have a decreasing value in the null detector. Keep in mind that for DC balance, the value in the null detector will be 0. But for AC balance, since there will always be some sort of noise in the circuit, it will not be equal to 0, but we will take the minimum value as the balancing point for the AC circuit. So anyway, this is our balancing point for the DC circuit, and the resistance here is 80, here it's 2 and here it's 0.8, so 82.8 ohms is the resistance of the S.